Yes. So here we're discussing the net present value technique of investment appraisal or capital budgeting. Capital budgeting is just how a business decides where to invest the money in, right? So this capital budgeting and this technique, which is called the net present value, we are going to use the time value of money concept to help us evaluate which investment is worthwhile, right? So we have a question here. It says, J Limited is a company that is deciding on where to invest their money. There are two investments that they can choose. So here, the two options that this company can choose, right? There's investment A and investment B. Okay, each investment costs 100 million kwacha. Okay, then when we invest in these investments, if you invest in investment A, in year one you expect to make 70 million, in year two you expect to make 90 million, in year three you expect to make 95 million. And you invest in investment B, in year one you expect to make 20 million, in year two expect to invest to earn 40 million, in year three expect to raise to earn 15 million. Okay, so we have to see which investment is worthwhile, which investment we should go for. All right, and we're going to use the net present value technique. So with the net present value technique, colleagues, what's going to happen is this money which we're going to receive in the future, kindly log out and log back in. I think that, yeah, try to log out and log back in. Okay. Are you able to see now? Okay, so now we're going to evaluate each investment using the net present value technique. All right. So if you remember from our earlier classes, the formula for the present value, we said present value PV equals future value 1 plus R, yes, power negative T. Yes. Sure. How about the others? Can you see the present? Maybe it's me who has to log in and log out. Oh, wait. Ish, I didn't share my screen. Ish, I did not share my screen. Sorry, colleagues. Sorry about that. Can we see the screen now? Okay. Whenever we start a class and you can't see my screen being shared, let me know in advance, okay? So I was under the impression I was sharing my screen the whole time. Okay, sorry about that. All right, yeah. So, as I said, this company, J Limited, is comparing two investments, investment A and B. So, as I said, with the net present value technique, colleagues, what happens is this money which we're going to receive in the future here, we're converting it into today's value, okay, for both investment A and investment B. And we're going to compare it against this cost to see if we get a positive or a negative net present value. Okay. Then I was saying this is the formula you need to remember, which says present value is the future value, open brackets, 1 plus r to the power negative t. Or other books you're going to see it as this: present value equals future value 1 plus r to the power t. Okay, 1 plus r to the power t. So this is the formula we're going to use to convert these future values. Okay, so just say here your year, your cash flow. Okay, then you say discount factor. The discount factor is this 1 plus r. Okay, colleagues, it's the 1 plus r. And then you have your present value. Okay, so our cash flows represent the future value. Okay, future values. Then the discount factor represents this 1 plus r to the power negative t. Okay, 1 plus r to the power negative t. Then our present value, we're just multiplying our future value plus the discount factor. So in the questions, you're always going to be given a discount rate. In this case, our discount rate is 10%. Sometimes this discount rate, they might write it as the cost of capital. Cost of capital is, think of it as the cost of financing. Okay, cost of capital, cost of finance. That's what you're going to use as your discount rate. So in this case, our discount rate is 10%. So for our discount factor, you just say 1 plus 10% in decimal form is 0.1 to the power negative t. And then 1 plus 0.1, that gives you 1.1. So discount factor is 1.1 to the power negative t. Okay, 1.1. Are we okay with that, colleagues? We just got our discount rate of 10%, converted it into a decimal, and added it to this discount factor. 1 plus 0.1, that's how we got 1.1. Any questions? Always. If there's no discount rate, the discount rate, if there's not, they'll always have to give you the discount rate in the question. If there's no discount rate, then you can't do this technique. Okay, so you're going to say year zero. Year zero, colleagues, just means first day of year one. We're assuming we buy this, we purchase or we invest in A, meaning we're going to invest 100 million. The reason why I've put a negative, because it's money coming out of our pockets. Okay, so I put a negative 100. Okay, then in year one we earn 70 million, so you just put 70 there. Year two, 90 million. Year three, 95 million. Okay. Our discount factor in year zero, it's going to be 1.1 to the power negative 0. Okay. Our value of t is just following the years. Okay. So here it's going to be 1.1 to the power negative 0. Okay. Then for year one, our discount factor is going to be 1.1 to the power negative 1. Okay. For year two, going to be 1.1 to the power negative 2. Here 3 is going to be 1.1 to the power negative 3. Any questions so far? And when you have a question, feel free to ask, okay, colleagues? Remember, in adult learning, you you must understand. You're learning to understand. Okay. In real life, let's say for example, if you're building a house, okay, you can say, okay, I built the house. Year zero, you say, okay, it costed me this amount to build the house. Maybe it costed you 300,000 kwacha. Then you say, okay, now what would I expect in terms of rent? After year one, how much rent do I think I'll accumulate? After year two, how much rent will I have? After year three, how much rent will I have? Then that rent that you'll be getting in those future years, you discount it into today's value and you compare it against the cost of your house. So your discount rate you can choose. You can use the inflation rate. If you got a loan to build the house and the loan's interest rate was 10%, you can use that. And you see if it's worth building a house. So let's get our calculators. 1.1 to the power negative 0 is 1. Always remember this. Anything to the power negative 0, anything to the power 0, negative or positive 0 is always 1. So your present value, you're going to say negative 100 times 1. That's so negative 100. The next one, 1.1 to the power negative 1. Let's get our calculators. Do we all know how to put the negative, how to put this in our calculators? Because it's very important that you know how to do this. In the exam, okay, in the exam, okay, how you do it on your calculator, there should be this symbol here, like a small house, like this. Or I think you have a YX, one of these two. So you would put 1.1, then you can, if you this symbol is there, you put this symbol, and then in brackets you can put negative 1. Okay. Or you can put 1.1 and then you press this YX, it will bring the power. Then in brackets you put negative 1. Try that. Let's compare our answers. 1.1 to the power negative 1. Are we getting 0.909? Okay. Is everyone getting 0.909? Okay. Okay. Then we go on the second one here. 1.1 to the power negative 2. What value do we get? Are we getting 0.826? Okay, then 1.1 to the power negative 3. What? 0.751, right? Okay, yes. All right. So once you've got those present values now, I mean those discount factors, now we convert. 70 times 0.909, we get 63.63. Okay. So this 70 kwacha that we'll receive after year one, okay, or in year one basically. It's worth 63 kwacha today. That's what this is telling us. This 70 kwacha, which you're going to receive in year one, which is the next year, today its value is 63.3. Then for the next one, 90 times 0.826, you get 74.34. Okay. Yes. So this 90 kwacha we're going to receive in year two. This 90 million we'll receive year two. Today its value is 74 million. 74 million approximately. And then 95 times 0.751, we get 71.345. Okay. Yes. Because the thing about it is this: if you ignore the time value of money, colleagues, okay, then whatever you're trying to calculate is not accurate. Because, as I said, if these investments we just added up here and compared with this 100 million, that's not going to be accurate. Okay, because as the years are passing, the value of the money is going to be reducing. Okay. So we have to account. That's why it's always important to account for the time value of money. So at least you can get accurate readings or accurate values. Then to get our net present value, we just add negative 100. So let's put on our calculators. Negative 100 plus 63.63 plus 74.34 plus 71.35. Tell me what value was we are getting. Are we getting 682.32? 682.32? Is this the value we're getting? Madam Evelyn, Mr. Trywell, Madam Cedar. Is this the value that we're getting? Say that value again. Hmm. What about maybe add negative on the 100? Yes. You say negative 100 plus this plus that. Let me see. Also, let me and first because 608. Oh, yeah, also inflated the number, me 63.6. So 109 point. I'm getting 109.32. 109.32. I put a 600 here. That's why I got a big number. 10, yes, 109.2. Are we all getting 109.2? Okay, okay. Yes, any questions? Okay. Any questions, colleagues? Any questions or queries? Oh, the question is here. This is the question. Okay. Okay. Yes. So, any questions on this net present value technique? It's consumer friendly, right? Is this consumer friendly, colleagues? When I mean consumer friendly, I mean in the exam you see this question, even start smiling because you know you're getting the full marks. That's what I mean, consumer friendly. Is it consumer friendly, Madam Sarah? Madam Sida? Yes, we're comparing investments. So we're going to look at now investment B. Okay. Now, if we're just looking at investment A alone, this positive net present value, as I said, it represents a gain. Okay. It doesn't mean that this is how much you're going to gain. No, it's just telling you that okay, your project is going to give you, you're going to gain some money from your project. Okay. It doesn't mean that that's the you should expect 109 million gain. No, these are just estimates. Okay, colleagues. That's why being director of finance, you have to choose the correct discount rate. And when you're forecasting what you earn in the future, that's where the trick is. Because if you inflate things, if you just put big numbers just like that, you get a positive net present value. You tell the company, let's invest. Then you find in reality, the investment brings you losses. Okay. Yes. Just as I said, even in real life, okay, if you are building, okay, this is how you do your investment appraisal. You say, okay, year zero, you just it doesn't mean that you build your house in one day, no, but you just get the total cost of your house. Then you estimate the rents that you'll be receiving every year. You total it up. So if you receive rent of 70,000, 70 million, rent of 90 million, rent of 95 million, then you discount it. They can say, okay, I expect the inflation rate to be 5%, or ex- the I borrowed money to buy to invest in this, and the interest rate was 10%. So I'll use that interest rate. And then if you get a positive value, you can say, okay, at least I expect this investment as a house to be a good investment. Okay? So now we're now going to compare to investment B. Okay, investment B 20 million, 40 million, and 50 million. So here 20 million, 40 million, and 15 million. Okay, same process. Same process. Okay. Our discount factor is still 10%. Okay. So let's get our calculators. Negative 100 times 1, negative 100. 20 times 0.909, what do we get? I'm getting 18.18. Yes, that's correct. Okay, then 40 times 0.826. 40 multiplied by 0.826, 33. Then 15 times 0.751, 11.26. Okay. So this 15 million you receive in year three, today in today's value, um, it's 11.26. This 40 million you receive in year two, today's value is 33 million. Okay. This 20 million you receive in year one, in today's value is 18 million. Okay. Yes. So we say negative 100 plus 18.18 plus 33.04 plus 11.26. We get negative 37.52. Negative 37.52. So according to the decision rules, if your net present value is negative, you have to reject the project. It's representing a loss. So basically, investment B, if we invest in it, we expect not to make money in the next 3 years. We'll be in a loss. Maybe as the years go on, okay, as the years go on, this will eventually become a positive value. So looking at both investments, since investment A has a positive net present value, has a positive net present value, 109, and it's greater than the NPV of investment B, because basically we choose the investment that has got a higher net present value. Okay, if investment B was also a positive number, we would have seen, okay, which one's giving a higher value. Okay, then the one with the higher value you choose. Okay, so in this case here we choose investment A. Yes. Any questions?